Students, in nitro compounds we are going to learn the chemical properties of benzene diazonium salt and one more topic, cyanide. Cn means cyanide. The cyanide, the suffix in IUPAC is nitride. One of the hydrogen in methane is replaced with the Cn, means we get methyl cyanide. That methyl cyanide, another name is acetonitride. Why it is called as acetonitride means on hydrolysis the methyl cyanide when add with water we get CH3COOH, that is acetic acid we are going to get. So based on this acetic acid, the name of this compound in common name given as acetonitride. CH3CN is called as acetonitride because on hydrolysis it gives the acetic acid. The next one, IUPAC name. It contains how many carbon? 2 carbon. So 2 carbon means eth and single bond ane. So ethane, and the suffix here we are going to write nitride. The Cn is nitride. So name of this IUPAC name of this compound is ethane nitride. The next one, C6H5, that C6H6 means benzene. One of the hydrogen is replaced with the Cn, means we get benzonitride. Common name is benzonitride. Why we called benzonitride means on hydrolysis it gives the C6H5COOH, that is benzoic acid. So that the name we are getting here benzonitride. In IUPAC we are going to write benzene and then the Cn is called as carbonitride because it contains one carbon along with the benzene. One more carbon is present, so that benzene carbonitride. Then rest of the lesson we are going to see what means preparation and chemical properties of cyanide and along with that chemical properties of benzene diazonium salt.
Benzene diazonium chloride undergo two types of reaction. First type is replacement reactions involving loss of nitrogen. In that one, first one replacement by hydrogen. So addition of hydrogen what we call reduction. So now we are going to do with the benzene diazonium chloride reduction with help of mild reducing agent like hypophosphorus acid. Another name is phosphonic acid. Formula H3PO2. In the presence of cuprous ion and then water. You see the first reaction, benzene diazonium chloride is C6H5N2Cl, then hypophosphorus acid H3PO2 plus water. In that water 2 hydrogen is there, 1 hydrogen goes to C6H5, so that we get C6H6, and another hydrogen goes with the chlorine in benzene diazonium chloride, so we get HCl. We have to remove the nitrogen N2 and one more oxygen is present in water. That oxygen added with the hypophosphorus acid, we get the phosphorus acid H3PO3. Then suppose that benzene diazonium chloride is added with the ethanol. Ethanol means you have to remove the 2 hydrogen from ethanol. Then 1 hydrogen goes with the C6H5. We get C6H6 and another hydrogen goes to Cl. So we get HCl and nitrogen we have to remove from the benzene diazonium chloride, and we removed 2 hydrogen from ethanol, so that we are getting ethyl alcohol, so that we are getting acetaldehyde CH3CHO. Another name is ethanol. When benzene diazonium chloride is reacted with cuprous chloride in presence of HCl, we get chlorobenzene on removal of nitrogen. Then same way, benzene diazonium chloride when reacted with the cuprous bromide in presence of hydrogen bromide, we get nitrogen is eliminated, and then instead of chlorine bromine is added with the C6H5, we get bromobenzene. And when the benzene diazonium chloride reacted with the cuprous cyanide, CuCN is cuprous cyanide, and in presence of potassium cyanide we get C6H5Cn. We are going to remove the nitrogen as well as the chlorine, so that we get the cyanobenzene. This type of reaction is called a Sand-Meyer reaction. Whatever naming reaction means it is a important reaction. Quatermain reaction. In this reaction, the benzene diazonium chloride is treated with copper with the help of hydrochloric acid. We get the chlorobenzene on removal of nitrogen. The same way, when the benzene diazonium chloride is reacted with the copper in the presence of hydrogen bromide, here also we are getting the bromobenzene on removal of nitrogen. But this reaction is somewhat related to the Sandmeyer reaction, but when compared to the yield, the Sandmeyer reaction is give good yield than the Quatermain reaction. Next one, replacement by iodine. For that, benzene diazonium chloride is warmed with the potassium iodide. The potassium taken away the chlorine from benzene diazonium chloride and nitrogen is removed. We get the C6H5I means iodobenzene. Next one, replacement by fluorine. This reaction is called as Ball's-Schiemann reaction. In this reaction, we are going to add fluoroboric acid, formula HbF4. Then we have to remove the HCl indicated in red box. Then add C6H5N2BF4. In that one, the nitrogen is removed. The name of this compound is benzene diazonium fluoroborate. In benzene diazonium fluoroborate, remove the nitrogen and BF4 is splitted as BF3 and F. So BF3 removed and F is attached with the C6H5. We get fluorobenzene. When benzene diazonium chloride is heated in large volume of boiling water, water split into H plus OH minus. The H plus taken away the chlorine from benzene diazonium chloride. Nitrogen is removed from the benzene diazonium chloride and C6H5 is attached with the OH. We get the phenol. And the next one, when the benzene diazonium chloride is reacted with the fluoroboric acid, we have already learned this reaction. That H and Cl, we have to remove it from that benzene diazonium chloride and fluoroboric acid. We get the diazonium fluoroborate. In that one, we are going to add sodium nitrite in the presence of copper. Then the nitrogen is removed from diazonium fluoroborate and the BF4 is added with the sodium. We get sodium fluoroborate. The next one, the NO2 is attached with the C6H5. We get nitrobenzene. When benzene diazonium chloride is reacted with the benzene in the presence of sodium hydroxide, one of the hydrogen is projected in benzene. That hydrogen taken away the chlorine from the benzene diazonium chloride and then two benzene ring will attach. The nitrogen is removed. Then that compound is called as biphenyl. Phenyl means C6H5. Instead of one hydrogen, one benzene ring is attached with another benzene ring. So this is called as biphenyl. This type of reaction is known as Comfort reaction. The next one, if you want to convert the aliphatic carboxylic acid into aromatic carboxylic acid, this type of replacement is very helpful to us. Instead of benzene diazonium chloride, here we are going to use the benzene. So far we studied benzene diazonium chloride girls. Here we are going to take the benzene diazonium fluoroborate, C6H5N2BF4. The BF4 I split it into BF3 and F. The F is reacted with the acetic acid. That acetic acid, the methyl alone taken away from fluorine, so that we get CH3F fluoromethane. And nitrogen is removed and then BF3 also removed, means the C6H5 is attached with the COOH, that is called as benzoic acid. Benzoic acid is a aromatic acid. Then acetic acid is a aliphatic carboxylic acid. So with the help of benzene diazonium borate, we are converting the aliphatic carboxylic acid into aromatic carboxylic acid. So far we studied replacement reaction and also loss of nitrogen, but hereafter we are going to study the reduction of diazo group, means here the nitrogen is never goes to lost. Then first one, reduction to hydrogen. What is reduction? Reduction means addition of hydrogen. So with the help of tin chloride bar HCl, zinc dust bar acetic acid, or sodium hydrosulfide or sodium sulfide, then addition of hydrogen going to be take place. Then benzene diazonium chloride, here we are going to add 4 hydrogen. The one hydrogen take away the chlorine, then another hydrogen, you split the nitrogen. One nitrogen it is attached with the one hydrogen, another nitrogen take away 2 hydrogen, so that we get the phenyl hydrogen. Phenyl is attached to NH2, that is called as hydrogen. Next one, coupling reaction. Coupling reaction means just you are going to add what compound you are going to add, just add by removal of HCl. So that is called as coupling. That coupling is take place in the para position. So suppose the para position is occupied, means ortho position is coupling will be take place. Then coupling tendency is increased when then para position is having the electron donating group. Then this coupling reaction is the electrophilic substitution reaction. Now see that benzene diazonium chloride is reacted with the phenol. Then para position of phenol, one hydrogen is one hydrogen is projected. That projected hydrogen taken away the chlorine, so that the phenol is attached in para position with the benzene diazonium chloride. Chlorine will be removed with the HMA. So we get para hydroxy. In para position, one OH is present, that is called as para hydroxy. Azo means 2 nitrogen and benzene is attached, so that the compound name is para hydroxy azobenzene, and it is a orange color dye. In the coupling reaction, we are getting a brightly colored azo compound. When benzene diazonium chloride is added with the aniline, one of the hydrogen is projected in aniline. That hydrogen combined with the chlorine, then we get para amino. Para position NH2 is present, so that it is called as para amino. Azo means 2 nitrogen, and we have benzene also. So para amino azobenzene we are getting. It is a yellow color dye. The condition for this coupling reaction is the pH level should be maintained 4 to 5, and temperature is 273 Kelvin to 278 Kelvin we have to maintain. Then benzene diazonium chloride, when it reacted with the para-crucial. Para-crucial means benzene ring. In para position we have OH and then methyl, that is called as para-crucial. In this both the para position is occupied, so that we are going to remove the hydrogen from the ortho position. I projected in red color. That hydrogen is taken away the chlorine from the benzene diazonium chloride. So instead of hydrogen, we are going to attach the N double bond N C6H5. So it is present in the second position. The first position is OH, second position is N double bond N C6H5, that is called as phenylazo, and in fourth position we have CH3, so 4 methyl, and it is a phenol. Benzene is attached to OH, means it is phenol. Then now we are going to see the uses of benzene diazonium chloride. When chlorobenzene is directly reacted with bromine, the chlorine is never replaced, so that we are never getting the bromobenzene by direct combination of chlorobenzene and bromine. The same way, direct combination of chlorobenzene and iodine and cyanide and OH and NO2. We never replace the chlorine by direct combination, so that we are using benzene diazonium chloride to get the bromobenzene, iodobenzene, cyanobenzene, phenol and nitrobenzene. It is a benzene diazonium chloride is a very good intermediate, and also we are getting the above this compound by replacement reaction. Then from the coupling reaction we get diazo compounds. These diazo compounds are they are colored, so that they used as a dyes. HCN means it is a hydrocyanic acid, another name hydrogen cyanide. It exists in another tautomeric form, that is that hydrogen is attached with the nitrogen, means it is called as hydrogen isocyanide. Instead of that hydrogen, If you put alkyl means it is called as alkyl cyanide. Then in the isocyanate, instead of hydrogen you put R means that is called as alkyl isocyanate. Then alkyl cyanide are called as in IUPAC name alkane nitrile. Then aryl cyanide in IUPAC name we called as arene carbonitrile. You will see in coming slides. For CN in IUPAC we put suffix as a nitrile. First compound CH3CN, when hydrolysis it gives acetic acid, so that in common name we put acetonitrile. In IUPAC there is 2 carbon, so eth and single bond, so ane, and then CN means nitrile, so ethane nitrile. The next one CH3CH2CN, on hydrolysis it gives propionic acid, so the common name is propion nitrile. And in IUPAC 3 carbon probes, single bond ane, and CN means nitrile, so IUPAC name propane nitrile. The next one CH3CH2CH2CN, on hydrolysis it gives putric acid, so that putreonitrile has a common name. Then IUPAC 4 carbon means but, single bond ane, and suffix is nitrile, so butane nitrile. The next one CH3CN and CH3, on hydrolysis it gives isobutyric acid, so that common name is isoputronitrile, and it contains 3 carbon linearly, so that 3 carbon means probe, single bond ane, and then in the second carbon we contain methyl, so 2-methyl propane nitrile. The next one C6H5CN, on hydrolysis it gives benzoic acid, so common name is benzonitrile, and in IUPAC name we write this one as a C6H5 is a benzene, and C for C we write carbo, and CN nitrile, as well as it is write as nitrile, so benzene carbonitrile. The next one linearly 4 carbon is there, so but, single bond ane, and then it is acid, so oic acid, butane oic acid, 3-cyanobutane oic acid. This compound containing 5 carbon, so that pent, single bond ane, and CN means nitrile, and then second carbon containing bromine, third carbon chlorine, and then methyl it contains, so that 2 bromo, 3 chloro, 3 methyl pentane nitrile. And method of preparation, for that first preparation from alkyl halide. For alkyl halide example ethyl bromide is given. That ethyl bromide is treated with potassium cyanide. The potassium is reacted with the bromine, so potassium bromide is taken away. Remaining we are adding means we get CH3CH2CN. Here 3 carbon is there, so probe, single bond ane, and CN means nitrile, so propane nitrile. Then aryl cyanide we cannot prepare by this method because it is a less reactivity towards nucleophilic substitution reaction. Then we get aryl cyanide by Sandmeyer reaction, we already learned in benzene diazonium chloride. Preparation of cyanide by acetamide formula CH3CONH2 when it treated with the P2O5. P2O5 is a dehydrating agent. What is dehydrating means? Removal of water. D means removal, hydrating mean water. So removal of water, you taken away the hydrogen, 2 hydrogen plus oxygen from the acetamide, we get remaining thing CH3CN, that is ethane nitrile. The same way acetal oxime formula is CH3CH double bond NOH. Here also we are going to take the water, I indicated in brown color. That water taken away means remaining thing we are having CH3CN, that is ethane nitrile. The next preparation is from ammonium acetate. CH3COO is called as acetate and NH4 is called as ammonium. So ammonium acetate, in that ammonium acetate also we are going to react it with the P2O5. That P2O5 taken away the water molecule. Here we are going to take 2 moles of water molecule, so that remaining thing CH3Cn, that is ethane nitrile. For large scale preparation only we are taking this reaction. The next one from Grignard reagent. Grignard reagent, for example, we are taking here methyl magnesium bromide. When it react with the cyanogen chloride, formula is ClCN. The Cl is taken away by MgBr, so we get MgBrCl. Then CH3 is attached with the Cn. Here we are getting ethane nitrile. Properties of cyanide. Lower member means up to C14 carbon is called as lower member in cyanide. They are colorless liquid. They have the strong characteristic sweet smell. And higher member means after C15, that carbon is called as higher member of the cyanide. They are crystalline solid and they are poisonous. And the cyanide are high boiling point than the acetylene because they have high dipole moment. The first chemical property is hydrolysis. Hydrolysis means addition of water. Then when water is added with the ethane nitrile in presence of hydrogen peroxide, and then one alkali means sodium hydroxide or potassium hydroxide, then water contain 2 hydrogen. The 2 hydrogen attached with the nitrogen and 1 oxygen, it is attached with the oxygen, means we get CH3CONH2, that is acetamide. Then once again that acetamide is hydrolysis in the presence of mineral acid. Hydrolysis means addition of water. The water split into HOH. The H is attached with the NH2, and instead of NH2 we are going to add OH, so we get the compound CH3COOH, that is acetic acid. When cyanide is undergo reduction with the help of lithium aluminum hydrate or nickel. Reduction means addition of hydrogen, so we are going to add 4 hydrogen. 2 hydrogen goes to carbon and 2 hydrogen goes to nitrogen, so we get ethanamine. Ethanamine means 2 carbon each and single bond ane, and then amine present, so that ethanamine, it is a primary amine. Next one, condensation reaction. First one is through nitrile condensation. This condensation undergo that nitrile which containing alpha hydrogen. Alpha hydrogen means Cn is a functional group. The functional group nearer carbon is called as alpha carbon. The alpha carbon containing hydrogen is called as alpha hydrogen. So in propion nitrile, the Cn is functional group. Nearer CH2 carbon is alpha carbon, so it contains 2 hydrogen. Then one of the hydrogen goes to another propion nitrile nitrogen. Afterward we are attaching these 2 propion nitrile in the presence of sodium, we get iminonitrile. See that how many carbon is present? 5 carbon, and that 5 carbon means pent single bond ane. In second carbon methyl, and in third carbon that C double bond NH is called as imino. So 3 imino 2 methyl pentane nitrile. And another condensation, that alpha hydrogen containing ethane nitrile with esters. Here we are taking ethyl propionate, the CH3CH2COO called as propion, and then C2H5 is ethyl propionate, that is ester. In the presence of soda amide we get the ketone nitrile. Here that C2H5O is called as ethoxy group by methyl nitrite. Methyl nitrite means CH2CN. Replacing we get 3 keto pentane nitrile. See that how many carbon? 5 carbon means pent single bond ane, and third carbon containing keto, so that it is 3 keto pentane, and first carbon nitrile, Cn means nitrile, so 3 keto pentane nitrile. It is this reaction is called as cyanomethylation reaction.